Hi everyone. Here we are going to discuss about trans effect. When we are discussing about substitution reactions in square planar complexes, we will come to know about the factors affecting the rate of those substitution reactions in the square planar complexes itself. So trans effect is one such factor we will discuss. There are many other effects also. We'll make video out of every effects one by one, but here we are going to discuss about the trans effect. Coming to the discussion, when we are dealing with reactions of complexes, we can see some ligands will not move their position, or it is not lost in the reaction. Those kind of ligands are called spectator ligands. So let's consider a general example. I'm writing it here. Consider we are having this kind of complex, here X, then here also we are having X. So in this reaction, here this L will be our spectator ligand. That means depending on the strength of this ligand, there will be substitution reactions in this position. I'll explain it once again. So imagine a new ligand Y is coming. So what happens is there will be a substitution in this position which is trans to our spectator ligand. This is our spectator ligand. Spectator means like an audience. Like if you are going to see some football match or something, there will be some audience for that. So those are known as spectators or audience. It's another name. So what happens is the ligand which is trans to the spectator ligand will be moving. So this X will be getting replaced by some other ligand. So product will be, this will be our spectator ligand, and here the new ligand will be getting attached. So the effect of this ligand, that means the spectator ligand, and our metal cation, here metal will be in a particular oxidation state. So these two effects which is involved in the complex. So the metal here can be any of the transition metals. It can be nickel, cobalt, iron, or anything. So both the effect of the spectator ligand and the metal cation, they have an effect, or they affects the rate of substitution reaction of ligands which are in trans position. So here trans means 180 degree. So the 180 degree corresponding to this ligand will be this X. So here this X will be getting replaced according to trans effect of this one, and there will be some contribution by the metal cation as well. This is known as trans effect. I'll repeat. It is the effect executed by the spectator ligand, or there will be a particular group of metal cation as well. So their combined effect is responsible for the replacement of this ligand. So the incoming group in the reaction, so here it is, the incoming group is Y. So the incoming group will go and sit in the position which is trans to the spectator ligand. So as a result, the incoming group Y is sitting in a trans position by replacing this X which was previously in the trans position. So there is a series, or we can say the labilizing effect of ligands has recorded according to their strength. So the series of the strength is going from high to low end. I'll explain. So first I'll write the series here. First will be your Cn minus, then CO, then NO, C2H4. All these are having almost similar strength. Then comes here PR3 AsR3, H minus, all these again have a similar strength. Then H minus, it is H minus. Then CH3, which is almost equivalent to SCNH2 twice. Then C6H5 minus, NO2 minus, I minus, then SCN minus, all these are having again similar strength. Then comes your other halogens, Br minus, Cl minus, Py, so then RNH2, NH3, these two are having almost similar strength, RNH2 and NH3. Then comes your F minus, OH minus, and last H2O. So here this the series which I have written is, their strength is from these position is having high strength, and here you are having the lower strength one. The ligands like the Cn minus, CO, NO, then C2H4, which are lying on the high side or on the high end side, they are the pi acceptors, and they have the capacity to show strong trans effect, or we can say these are strong trans directors. On the other hand, the ligands which are lying on the lower end like OH minus, H2O, which are on these weaker section or weaker side, they are very poor in trans directing, or we can say they are poor trans director group. A strong trans director has the ability to promote rapid substitution of ligands which is trans to it. So here any of the ligands, Cn minus or CONO is there, then what happens is this effect, or we can say the strong effect of these groups will be executing a very rapid substitution reaction. As a result, this X will be replaced very fastly by the incoming ligand. The same way we can say here you are having the lower trans directing group. So if such groups are present in this position as a spectator ligand or in the position of L, the substitution reaction carried out will be in a much slower rate, because these ligands do not have that much capacity to exhibit rapid substitution reactions. Then there will be often confusion between the terms trans effect and trans influence. Trans effect is entirely different from trans influence, and this trans influence is a thermodynamic process. It doesn't have any role in this section, so we'll discuss in some other video. So this is all about your trans effect. Thank you.